Based on the illustration we have mentioned, we believe that the following formula is true. In particular, when we consider expanding 1 plus x all to the power n, we believe that this formula is correct. We shall prove both of them by mathematical induction. Let us first prove that this statement is correct with n to be an integer greater than or equal to 0. We proceed by taking the induction on n. First, we already know that this result is true when n equals to 0 and n equals to 1. We can observe it by taking n equals to 0, so right-hand side is equal to 1. And when n equals to 1, we observe that right-hand side is also equal to 1 plus x. Now let us suppose that this statement is true when n equals to m. It means that we assume that the binomial expansion equals to the sum of these terms, which is m choose 0, m choose 1 times x, plus a lot of terms until m choose m times x to the power m. And we say that x to the power r is the general term in this expansion, which is of the form m choose r times x to the power r. We write more formally that with this summation symbol, the binomial expansion of 1 plus x to the power m equals the summation of all the terms with general pattern m choose r times x to the power r, where r starts from 0 to m. We'll notice that our induction hypothesis is that the coefficient of x to the power r is m choose r. Now we want to prove that the corresponding formula when m becomes m plus 1 would be this formula. So we want to show that it follows from our hypothesis that the coefficients of x to the power r in this new expansion is changed to m plus 1 choose r. We want to make use of our induction hypothesis. Therefore, we rewrite this expansion to be the products of 1 plus x to the power m and 1 plus x. It means we have this right-hand side of the statements from the previous page when we have the power to be m times 1 plus x. After multiplying out the terms, we get this longer expression. And we make use of the previous formula that the sum of m choose r minus 1 and m choose r equals the binomial coefficient m plus 1 choose r. Therefore, we can see that whenever we have the common terms x to the power r, we will add these two values together and get a new binomial coefficient. And we have combined the like terms in this way. And therefore, the binomial formula for 1 plus x to the power n is correct. Now, we would like to use this special case to prove the expansion of the more general binomial expansion x plus y to the power n. This can be done by first of all rewriting x plus y into x times bracket 1 plus y over x. And therefore, all this to the power n is equal to the product of x to the power n times this bracket to the power n. And this bracket has the format 1 plus big X. Let us treat big X to be y over x. And according to the previous formula, we have this right-hand side binomial expansion. And after we distribute the x to the power n to each of the terms here, we get this expansion, which is the same as the right-hand side of the formula we come across before for x plus y all to the power n. Therefore, we also proved that that formula is correct. And I would like you to remember this formula for the binomial theorem, which states that when we have the expansion for x plus y all to the power n, it can be given by the summation of all these terms, which the general term is with a coefficient n choose r times the term x to the power n minus r times y to the power r, where r starts from 0 to n. This formula helps us find the coefficients of a certain term in the binomial expansion more conveniently. For example, if we want to find the coefficients of x to the power 5 in the expansion of 2 minus x all to the power 7, we can make use of the binomial theorem to get it more conveniently by first rewriting this expression as 2 plus negative x to the power 7. Then we can treat 2 to be x and negative x to be y and n to be 7, and by binomial theorem we get this formula for the expansion. We notice that when r equals to 5, then we will get a term containing x to the power 5. This term is 7 choose 5 times 2 to the power 7 minus 5 times negative x to the power 5. And therefore the coefficients of x to the power 5 will be those numbers which is attached to x to the power 5. This is having a value of negative 84.